Here's an example we've already seen, but I wanted to revisit this example now based on what we just learned about triple bonds. So how many pi electrons are there here? Well, obviously there's 6 pi electrons in the pi bonds, and we know that this nitrogen has already used its p orbital for this pi bond. Therefore, this lone pair has to be in an sp2 orbital, and therefore this lone pair does not count as pi electrons for Huckel's rule. So we'd only have 6 pi electrons. So we already saw this example, and we explained why we can't count the lone pair as pi electrons for Huckel's rule. We can't count the lone pair as pi electrons because this nitrogen has already used its p orbital for the pi bond. We know that the pi electrons are the electrons in the side-to-side overlapping p orbitals. If you've already used up your p orbital for the pi bond, an sp2 atom doesn't have any p orbitals left for the lone pair. But now you can see that that explanation that we gave earlier was a little bit superficial, or at least there's a little bit more to it than that. There's another reason why we can't count this lone pair as pi electrons. So before we said this can't be pi electrons because the nitrogen only had 1 p orbital, which it had already used up. But there's another reason that we can't count the lone pair as pi electrons, even if this lone pair were in a p orbital. Let's just suppose that somehow the nitrogen looked under the couch cushions and found another p orbital. And let's say this nitrogen was able to put this lone pair also in a p orbital. This lone pair would still not be part of the completely conjugated system of p orbitals, because the nitrogen, we already know, is using this p orbital to overlap with the other p orbitals in the ring. This p orbital, even if it existed, couldn't overlap with the other p orbitals in the ring because this p orbital would have to be perpendicular to this one over here. Remember that one p orbital on an atom is always perpendicular to any other p orbitals on the atom. We already know that this p orbital is overlapping with the other p orbitals in the ring. Therefore, even if the nitrogen somehow had another p orbital, that would be perpendicular to the other p orbitals in the ring. And then we would still not count this lone pair as electrons that count in Huckel's rule, because the lone pair, even though it's in the p orbital, would not be part of that completely conjugated system of overlapping p orbitals. All right, and now we can see then that there's really 2 reasons why we would not count this lone pair as we would not count the lone pair when we're working with Huckel's rule. First of all, because in fact, the lone pair is not in a p orbital. And secondly, even if it were in a p orbital, that p orbital would be perpendicular to and not overlapping with the other p orbitals in the ring. Okay, I wrote down a p here just because, remember, we were pretending that I wrote down a p here just to figure out what would happen if this lone pair were in a p orbital. But remember that in real life, the lone pair is not in a p orbital. It would be in an sp2 orbital.